twice.
But John, I think you learned different, right? You learned Spanish on Duolingo. You learned Spanish. I would give you two. Good. You also test Spanish.
Eu me llamo Kate. A mí me gusta español.
You know, after it's like.
A mí me gusta español. Chile. For me, it's so good. I learned French.
Okay, guys. Let me introduce myself. My name is Harish Srivastava, and I will be a professor for this subject called as Assessing Big Data. About me, I work with the RBC as a director for quality engineering and big data for almost like 7 years now in RBC. I have 20 years, close to 20 years of IT experience working across the globe in London, UK, Germany, US, Canada in last 10 years now. Okay. I'm not sure how much of you all have studied about big data, but as you all know, it's one of the most burning topic in last few years. You have many jobs openings that are related to this topic. Knowing this is good for your career. I feel like it's something which, as an experienced professional for 20 years, I am also learning with the changes that are coming as part of the technology. Okay. If you have any questions with me, asking any topic which you want to have a discussion with me, you can book me a meeting, set up a meeting WebEx with me, and I can help you out. Okay. Normally, I'm busy in Monday to Friday with my regular office work. I'm good at close to around 4 to 7 in the evening. If anyone wants to have a session with me to understand more about it, you can just book me, send me an email saying that I want to discuss on this topic and I can help you out. Okay. Just to give you a background, I think you all have heard about AI, right? So this course basically starts with big data, and eventually in the final sessions of week 12 and 13, we are going to learn something called as machine learning. Okay. So I will be teaching you something that is practically used, how it is used in industry and how you solve those problems. Most of my content which you see is very similar to what Seneca says me to teach, but my examples would be very, very closely resembling how we do it in our organization. Okay. So how we do in our organization, how we manage it. This is more of a theoretical slide deck, but my examples would be more of practically how we do it in our organization. Okay. If you don't understand something, let me know. Ask me 10 times. I don't have a problem. Okay. I want more of an interactive session. And your assignments and details about that is, I think you have total of 8 or 7 assignments to be completed after each week's. 1 quiz will be there and 2 exams. 1 will be midterm and the main exam. Your grading mechanism would be a weighted average. You all might have been knowing it, right? By now, it's a weightage for each of the assignment and the test. Based on that, the total sums up to 100%. Okay. So what we will do is we'll have a quick introduction of everyone one by one, and just tell me what you have done as part of your education career and what skill set you have, because that will help me to give you an example that closely resembles this topic. Okay. Yes, we'll start with the last one. You can come in front because it's very difficult to talk louder, and I am very tired from Monday to Friday from my office work. So this is the evening class, so I will try to be loud as much as possible.
Okay. In the class, my name is Emmanuel Atta.
On my background, electrical electronics, engineering, and my experience back home, I worked in the bank as customer service representative.
Just to ask one thing, how many of you have studied maths till grade 10? Everyone, right? How many of you have or may able to recall something which you studied related to statistics, mean, median, mode? Right? That's why I say the AI is good, machine learning, AI, big data is good for people who are just graduated or have just cleared grade 8, 9, 10, 11th and 12th, because it's very closely resembles the concepts of statistics. Okay, so if you like that topic in your course, when you studied maths, this will be very easy for you. And that's why you will see newbies are mostly on this area, right? Okay, thank you. Please go ahead.
My name is
We'll do quickly, okay?
Okay, my name is Jay. I have an educational background in accounting and risk management.
Okay,
And back home, I used to do, I'm still doing it. I'm an auditor and on the less busy seasons, I'm working as a consultant.
okay. So you do accountings. So you play with numbers, right? So this topic will help you to understand and analyze something which is related to how AI works. Yes.
Oh, hello. Good afternoon. My name is Aaron Kim. I call me Kim. I have a degree in electronics and engineering back home from the Philippines. So my experience is most likely IT related to healthcare and gaming. So I work with infrastructure as code and mostly like DevOps.
You worked in cloud?
Yeah.
Okay. Good. Yes.
Good afternoon, Prof. So my name is Joy. My educational background is in management accounting and professional background is project documentation.
This semester I'm not teaching project management, so I can't give you any guidance on it. Yes.
Hi, Rob. I'm Zarina Navarrete.
A very tough name.
What?
Simplify for me. How should I call you?
You can call me Z.
Z, okay.
And I have a degree on computer science and information technology. And I have experience in software quality assurance testing and automation testing. So
Automation testing using which tool? Selenium? Okay.
Yes, hi, my name is Ronald and I have a background in computer science and I mostly do systems administration and yeah, that's mostly it.
System admin. Okay. Yes.
Yeah, my name is Jay Kumar. I'm from India and I have a degree in computer engineering.
Which year? Recently?
Recently, in 2020.
So basically a fresher almost.
Yeah.
You have work experience?
1 year.
1 year. Web developer. Okay.
Hi everyone, this is Gianni Profil. I have graduated from computer science and information technology and I have a background in full stack development using React.
React. Okay, good.
Hi, I'm Akib. I have completed my bachelor's in computer science and I worked as an IT manager at web development.
Good. Okay. So you moving from a manager to a non-managerial role. It's good. Even I'm in management for last 10 years, but it's very boring. Yes.
My name is Adil and I have a bachelor's degree in special technology. And I used to work with apps, games, websites, and I still do that. But my stuff is mostly management. But I'm moving to database now.
Database, okay. So you have a hands-on skills on database, basic queries, understanding relational database and all those stuff.
Yes.
Okay. Because we would be understanding that also in big data. Yes.
Hi, good afternoon. I'm Aurithro. I have a bachelor's from home in computer science and my professional background is managing data for real estate companies.
Manually.
Not manually, automated.
How do
Using
you?
Excel and.
Oh, okay. Excel data set. Okay. Okay, good.
Thank you.
Yes.
Hi, Prof. I'm Yang. I have the bachelor degree in IT and accounting, and I work as a system business analyst. I think that's all.
Okay. Yes. We'll do quickly. Come on, faster.
Hi, I'm Sai. I have a bachelor in computer science and a master in cybersecurity. I used to tutor as a Math and Python tutor,
And right now, I'm running a YouTube channel named Tech with Baby. That's it.
I can watch your YouTube channel. Okay.
Definitely.
You can watch my YouTube channel as well. We will increase our subscribers. Yeah.
My name is John. Bachelor degrees in computer networks, and I've been a network engineer for a couple of years.
Good. Yes.
Hi, Prof. I'm Lynn. I have my degree in economics, and for my work experience, I work as an ERP consultant.
ERP consultant. Okay. So you worked on SAP and all those tools.
I work in Microsoft Dynamics 365.
Microsoft Dynamics. Okay. Yes.
Hello, Prof. My name is Rahul. I'm from India, and my background is from Bachelor in Computer Application, and I have experience in quality software, like software quality assurance, basically.
Automation or manual?
Manual.
Okay.
Hi, Prof. My name is Shivam. I have completed my degree in computer application background, and I don't have any professional experience, but I have worked as a graphic designer and a 3D artist.
Okay. Yes, ma'am.
Hi, Prof. My name is Tanuji. I have a degree in business information systems, and I have no work experience.
Good. If you don't have, then it is easier for teaching. Yes. Okay.
I completed my bachelor's in computer science, and I worked as a software.
How long did you work? 4 years. Back home? Okay. Which technology? ServiceNow ticketing system. Everyone uses it. How many of you know ServiceNow? Good.
This is Prashanjit Banik. So I completed my undergrad in electrical and electronics engineering, and I worked as a network administrator for like 3 years.
Okay.
Hi, Professor. I'm Senduran, and I have a degree in software engineering, and I worked as a web application analyst for 2 years.
Back home. Okay. Which technology you worked?
WebLogic, which is for Java applications.
WebLogic. Yes. Yes. Okay.
Hi, everyone. My name is Grishma, and I have my bachelor's degree in electronics engineering. And I was a software engineer at Capgemini for 2 years, where I worked on a tool called Click.
My vendor is Capgemini. I have people working within my team who are Capgemini.
Hi, my name is Bilal, and I have my bachelor's degree in computer science, and I have been working for 4 years as a technical support engineer.
Okay, like defect management or technical support for the infrastructure?
Basically, it was a fintech company, and we used to work with databases to solve issues.
Okay. Thank you all. So regarding my education qualification, I did my BTech in 2002. And then I did my MTech from computer science in 2004. And thereafter, I'm teaching sometimes. Mostly I'm in IT, so you can find me in 20 years of IT experience. Okay, so we'll start with assessing big data. Yes.
How can you join the meeting?
Okay, I have not shared the Zoom link, right? Yeah, I think
Live is also loud.
no, it's open. No, it's open. Okay, I just send a Zoom link to you all. Basically, I'm having this Zoom link for people who are not able to attend the class. So, but I would recommend you attend the class because it's easier to understand. Okay. So, couple of slides in the beginning. This deals with data analytics versus big data. There is some of the links which you all can go through it. I'm not going through it. It's just a white paper and some documentation that is written, an article that are written on the concept of big data. If you don't want to go through it, fine with me. Okay. Okay. So first, let's understand what is a big data. So what is a big data? Think about in a situation where 20 years back when we were managing the data set, we were managing the data set using a normal database system, either being Oracle or Microsoft Access or SQL Server, right? What was the challenge with that data set? Any idea? Take 10 years back, 15 years back. Don't read the slide. I will explain you all what is written in the slide, but first understand what's the concept of big data. Come on, guys, who are there? It's okay. Why you want to be there? I don't know. What's the point of being there in admit? Okay. So the concept of big data comes 15, 20 years back when internet started being used by many of the people, right, around the globe. We started with developing our application using front end, right? You have a UI and you used to have a backend system called as database system, right? So let's think about a situation where you have a database of students of a college, right? We started inserting the data with a simple command called as insert statement, right? And then we used to update it and whatever, delete it and whatever we wanted to do it. With the technology moving more and more to a volume of data being growing. So think about is, if all of you have used Facebook, right? Everyone has used Twitter or whatever we call it, X, right? Or any social media. How much data we are uploading every day? Huge volume, right? So first challenge was the growth of the data in the terms of volume, right? If you start putting that data into the database, what used to happen? The database becomes slow, right? Another situation is people who have worked on the database, right? They might have used SQL Server or SQL or Oracle. When they install the SQL Server, it gets installed on your machine, right? Where are the tables installed? So let's say you install a database in your machine, right? You go to SQL Server and just download it, install on your machine. And now you create a table, create table employee, right? And within that table, you start inserting the data. Where is the data getting stored? So there are two storage space, right? One is your hard drive, right? SSD, whatever you call it. And the second is the main memory, right? Most of the data, or I would say every data which you are creating were stored in your disk, right? So what are you going to do? More and more data gets stored. You started increasing the database size, right? So let's say your hard drive was 30 gigs, then you extend it to 60 gigs, then 120 gigs. So there is a limitation, you can exceed it, right? The data, when it is exceeded to a certain point, what do? You partition it, right? You break it down and you store it into different location, right? But end of the day, data was stored in the disk. The challenge is whenever you are reading a data from a disk, when I'm saying disk means your hard drive, right? So when you're reading a data from your hard drives, the performance is slow. Because how many of you people understand how disks work? Do you all understand how disks work? You have a main memory which is called as RAM, right? Main memory is RAM where your operating system runs, your processes run, right? Disk is a system like your SSD or a hard drive, right? Where the disk data is stored. Whenever you're reading a data from a disk, there is a latency involved. A lot of time is consumed to fetch the data and give it into the front end system. With the invent of the increase in the volume, right? The challenge was how quickly we can get that data, right? Because the volumes are growing. Let's say example Facebook. Let's say example as a YouTube. You're uploading 100 and 100 gigs of data every minute. If someone wants to retrieve a data and the data has to be retrieved from the disk, it will take minutes to retrieve, right? In order to solve the problem, the concept of big data came into picture, okay? So big data, as implied by its name, big data refers to an immense volume of raw and unstructured data from diverse sources. Why we call it as a raw? When you created a database, and everyone have studied somewhere, maybe at a high level, relational database management system, RDBMS, right? A database having a table and columns are related to each other with a foreign key or primary key constraints, right? Just understand the basics, right? You create a database. Database is nothing but a collection of objects or tables which are interrelated to each other, right? All those data, let's say I created a table called as employee, and employee has a column called as first name, last name, employee ID, address, phone number, right? Correct? If the employee column, employee name column is string, can I put a number there? Yes.
Yeah.
Let's say, for example, if the age is there, can I put alphabet there? It's a integer, right? Why can't we put? Because it's a data type that is being defined. The problem with the unstructured data or raw data is in the current time, your data set is not structured. For example, if I want to study a log, server log is like a notepad file, right? With the data written as IP address, comma, host name, timestamp, some error, log, info. It's unstructured, right? Some data can be alphanumeric, some data can be number, some data can be character. How are you going to store that data? A traditional way of storing the data into RDBMS will not work here, right? So that's the reason it is called an immense volume of raw. Raw means data which is not predefined into a specific category or type, right? That's the reason we wanted to move it to the big data, okay? Second is unstructured data. Unstructured data means a data not having a specific pattern. Okay, so let's say employee table, I told you it has got a column with set of certain data set, right? With first name, last name, age, address, phone numbers, right? Think about a data if I give you, which is in a form of a raw data in form of a text file. Some field may be empty, right? Some field may have special character. Can you insert that data into the database table when the database table is defined with specific data types? It's not workable, right? So that's the reason you have the concept of big data coming into picture. Diverse sources means now data doesn't come like a single source of system, right? When you used to create an application 15, 20 years back, you used to have one database, one front end, one middle tier, right? API or web services. Whatever data being inserted from anywhere across the globe get sit inside a single database, right? The source was one, like the input where the data was coming was only one. That is your front end application, right? Now think about a situation where data is coming from multiple sources. Okay, I give you my example in my organization. Okay, I work on a wealth management line of business within RBC. Okay, it's one of the line of business within wealth management. Okay, you have RBC insurance, you have RBC core banking. Core banking means the banking you all do with your app, right? The branches, right? You have RBC capital market, right? Now, each of us in the line of business are using a customer account, right? So if I have a RBC account which is having a account number, so my detail will be there in the core banking, right? The same detail needs to be migrated to other wealth management or a capital market or insurance. I don't have to create 10 different databases. I can have one database that can cater all the requests, right? And validate it. So my source is diverse. People are logging into different application front end and using the application, knowing the data is already there. Or they're inserting the data into the database from the diverse sources. For example is, you have seen people are posting YouTube videos on Twitter, right? Both the system are separate, right? They are from diverse source. How should we integrate it together so that they can talk to each other and get the data what we need? Third example is data coming from diverse sources. I want to monitor my home system. Okay, home system means I have a, let's say, digital lock in my home, which goes with a password. I have an air conditioning system, which is there as a thermostat. I have a TV that can be controlled using my mobile app, right? I want to know how the usage of all these devices are going through together. The device which my digital lock will be sending a log will be of different format. The device which is of thermostat will have a different log format. The device, my application for TV will be a different format. All these data are coming from different sources, but they are accumulated in a single place, and I need to analyze that. For that, we need a big data analytics. Okay. Owing to its high volume and high veracity nature, it is often require more computing power to gather and analyze. So big data basically deals with four things. One is called a data volume, which I explained you, the massive amount of volume of data. Okay. Data velocity means the modern care, like think about the speed at which the data is growing. Velocity basically means the speed the data is growing. So every day, how many people are posting their videos on, let's say, YouTube? Millions of people are posting, right? The velocity of the data is growing at many folds, right? Data variety means the data having different categories. Some may upload only music videos, some may post only the text data, some may post only the let's say MP3, MP4, different categories, right? Some may post video data format, whatever you call it as, right? So there is no specific data format that is defined, but we allow all the data to be inserted. Okay. Data veracity means poor data quality. Basically, when the data is created, there is no governance of data quality, right? You cannot control person's data quality. I can upload any format of data in any quality, right? As a big data setup, you need to control that, control the accuracy and control the quality of the data, right? So the data can be, as I tell you, there are data set which may have empty field versus the data set which is complete set. How to handle that? In a normal database system, if the particular column is defined as not null, you cannot insert the data, right? If you try to insert and you pass an empty data, it will not get inserted, right? But in big data, if the data is incomplete, then also you can insert it. Okay. So the term big data was first used by John Mashley to refer to handling and analyzing massive data set. The concept of big data gained strength in early 2000 when Doug Lanley defined big data as 3 V's. Now it is moved to 4 V's and we have now called as 5 V's. Anyone knows what is the 5th V? Volume, velocity, variety, and veracity. What is the 5th V? 5th V is value. Whatever data you are storing, that data should have a value. Okay. Don't get worried. These are all theoretical things. Just can read it. By definition, big data refers to large amount of data that increase fast and is difficult or even impossible to handle by a traditional method. Okay, let me give you an example. Okay, if I ask you a question, what is the relationship of eating an ice cream and a person getting killed by a shark? Sorry? Okay, the question, I'm just giving you a thought process to understand how big data and big data analytics works. So think about a situation. If I have a data where I have a people eating ice cream, okay? And the second data set, which is related to people getting attacked by shark. Can you define a correlation between the both?
Eating. Yeah, during summer, people go for swimming and also
Exactly.
they eat ice cream.
So during summer, what happens is a lot of people eat ice cream and they go to beach, right? And during beach, they swim and they can get attacked by shark. So if I give you 2 data set of 2 different diverse sources, right? When I say data set means a data form of an Excel, think about it. And I want to correlate and I want to analyze using machine learning, saying that, okay, what is the chances or what's the probability of getting a person attacked by a shark in summer when he or she is eating ice cream, right? So that level of concept comes in part of big data analytics, okay? One part is the data accumulation. Big data deals with collecting the data from different sources and creating a database. I should not use the word database. Think about a volume of database repository. One aspect is collecting the data and storing it. The second aspect is once you have stored the data, how would you analyze it? Okay, so that part, analyze it, is called as data analytics. Okay. What is big data analytics? Data analytics seeks to provide an operational insight into the business. Operational insight into the business means it gives me a value what that data tells me. Okay. For example, you all have seen, and I think everyone has seen this. Everyone has used Amazon, right? Everyone has it. Have you purchased anything from Amazon? Right. So let's say I want to purchase iPhone cover, right? I purchased it. I go to proceed to checkout and I purchased it. Next time when you log into Amazon, what does it show you? You may also like this, right? This is a good deal. This has got 30%, 40% discount or something closer match to it, right?
Yes.
That concept comes with the insight onto the business. Okay. Another example is how many of you have used Netflix? Right? Everyone has used maybe Amazon Prime, right? Whatever you call it. If you watch a certain type of seasons or a drama or something like an action, right? It will tell you that, okay, you may also like this, right? Where does that analytic comes from? That analytics comes from the insight of the data which you have provided. Based on viewing patterns, based on your viewership, whichever category of the data you are viewing, it tells you that this is the data set you should watch. Okay. It considers historical data and then draws out inferences from them to find a better solution to a complex business problem. So whenever data analytics comes into picture, it mostly deals with the historical data. Okay. So let's say, for example, I want to see how many people are using the mobile app for RBC, right? So what should I do? I should take out the historical usage of my mobile app login sessions, right? So if I see based on each of the customer account, I can understand how many people are frequently using, how many people are not frequent user, they still like to use through browser, right? So that type of details can be collected from the data analytics, okay, or analyzed. Data analysis is conducted at more basic level, whereas data related to the problem is specifically scanned through and parsed out with a specific goal in mind. So many of the data are historical data, but in a real time, now we are analyzing a data which is appearing in a real time. For example, if you use your credit card, right? If you're using your credit card and someone hacked your credit card, let's say you are using your credit card and you gave your credit, it got hacked by someone and that person is trying to access that credit card from a different geographical location. You will find after a couple of times that credit card gets locked automatically, right? How it is happening? Because there is a system in place in the background which is continuously analyzing your data in real time with a specified goal in the mind. Let's say I'm using my credit card mostly in Canada, right? If suddenly an IP address with my credit card being used from Japan, the system gets triggered as an alert and locks it, right? As a person who is not intended to use, right? So with that specific goal in mind, another notable difference between two is that big data employs complex technology tools like parallel computing and other automation tool to handle big data. So what tools we need to know, I will be explaining you. That is called, we will be studying something called as Hadoop. Okay. So Hadoop is a big data concept. Okay. So that tool is used for storing the big data. Okay. And analytics is used for machine learning. Okay. Data analysis use predictive and statistical modeling with relatively simple tool. You have seen that if you see, since you all are from new in Canada, like how many of you see weather channel every day in the morning online? Like how is the weather today? Weather, right? So you will see they are forecasting something, right? How they are forecasting? They are forecasting with the predictive analysis. What they are doing is they are taking the data set on the historical data as well as the real-time data, and they are analyzing it and predicting what's the weather going to be there in the next couple of weeks or couple of days, right? So that's a part of data analytics. So how does big data analytics works? So it involves 4 steps for data analysis. One is called as data collection. Basically, that's done by the big data Hadoop. Okay, like collecting the data from different source. Second is called as data pre-processing. Once the data is collected, we need to see whether the data is pre-processed. Like, is there any empty fields? Is there a incorrect field that is being added, or all those stuff? Then you do data cleaning, like you remove unwanted data or duplicate data. And the last step is data analysis. Once the data is cleaned, then you do the programmatical way to analyze the data. We'll see into the details, but this is the basic concept of big data and data analytics. Any question till this point? You can ask questions, right? Okay, so before going to the next subject, the topic which we are going to discuss as part of an application is called as Hadoop. Okay, we'll start in the week 2. Just to give you the background, Hadoop is a very, very basic big data concept. Okay, when you go to the industry, you might not use Hadoop. Okay, so there are many products in the market which are used, but the concept of Hadoop still there. Okay, so you would be hearing many of the terms, like my organization uses a big data concept called as single store. Previously it was called as MemSQL. Okay, again the concept is big data. Other is called as data lake. There are Databricks. There are many companies which are selling the product as part of big data, but the concept still remains the same. The operational part of it, like how the conceptually it works, remains the same. The term of the tool changes. Okay, so if you go in the organization and say, oh, I know only Hadoop, I don't know how to do it in single store, you shouldn't be saying that, because end of the day, only the syntax will change how you are going to use it. The rest, the concept still remains the same. Okay.
Is Hadoop like Tableau?
Tableau is
Visualization.
a data representation of the stored information. Okay, it's mostly used for reporting purposes, but again, it uses the concept of Hadoop to extract the data and analyze it. It's a big data concept, but it's a reporting part of big data, analytical part of it. Okay, storing of big data is, think about, there are two parts of big data. One is storing, right? You want to first store the data, then only you are going to analyze it, right? So even in Tableau, you have a database that stores the data. So the data that gets stored needs to be understood how it is getting stored. It's not stored in the way you think the relational database system stores. In the normal relational database, you create a table, you start inserting, updating, deleting the columns, right? Or adding the rows, right? Relational database have a concept of called as primary key and a foreign key concept, right? Everything is stored in the disk, right? In a big data, nothing is stored on the disk. Some things are stored in the disk, but predominantly most of the things are not stored in the disk because it has to be fast. We are talking about a data which is, let's say I give you an example. In my organization, every night we are loading close to 294 gigs of data every night in one line of business. So basically I deal with a trading platform, the stock market, right? Where you, yes.
So if is this Hadoop, we need to program this from the very start. Like if I am building a website, I do have to integrate it from the very start, or I can integrate it into a existing.
You can integrate to the existing also. So basically Hadoop is an installer, right? You install it and then you configure it, right? Only thing you have to do is you have to configure the front end to get call the Hadoop system. Okay. Okay, what I was saying. So I will give you an example. Okay. So if I have to load 294 gigs of data every night into a database, how quickly my database will grow? Maybe next 4 days it will be 1 terabyte. In a month it will be close to 25 terabytes. If the way I grow the database, how quickly I can access it? It will be very slow, right? Even if I create a database with thousands of connections, and I'm talking about a trading platform where every second we are having close to like 40,000 transactions. Every second. Every second we have 40,000 calls that are made to the database to get a stock price. If a delay of 1 second is also there, the rate of stock changes, right? You're going to purchase at $5, suddenly it becomes $7 or maybe $2, right? The customer will complain, right? So you need a fast system of storing the data as well as extracting the data, right? And the performance should be close to microsecond and milliseconds. We have application that responds in, let's say, 200 milliseconds. Your front end gets refreshed in 200 milliseconds, you don't know even it has happened. Okay. So first part is how to store the data. And the second part is how to analyze the data. Up to this point, we are clear? Yes.
Hadoop is going to be for the data storage, right?
Hadoop will be going to be for data storage, correct?
be like for the system, but big data is going to replace
Traditional system, yes, yes, yes. Correct, perfectly. We have almost, most of the big organization have migrated from the traditional RDBMS system to a Hadoop-based big data systems.
So the data actually stored in Hadoop now, and like you want to access and like properly process it directly with Hadoop, right? Not moving it from like, I'm just wondering like whether after using Hadoop for some kind of processing and analytics, are you guys going to move it from Hadoop to another system as well? Or
No, no. So think in this way. Let's say your application is being built on a database, a normal Oracle database, okay? The Oracle database is stored in disk and you have, let's say your company is using cloud to store the data, right? When they are using cloud, think about even they are using cloud, they are storing the data in a formal traditional RDBMS system. Basically, they are creating a table, they are storing there, they have entity relationship diagram, they have schema design, everything in the cloud disk. But the data volume is growing every day, right? End of the day, the data which is stored in the database is not sitting there, right? Someone will be consuming the data. Who will be your consumer? The people who are using the application, right? If those people are trying to access that application data, if the slowness is there, they're not going to use the application, right? So basically they want a system which is more scalable. Scalable means that can grow as much as possible. Second, efficiency means it should be efficient in terms of quickly retrieving the data. Fast, robust, right? So what we are doing in last, like we started our migration of our traditional database from 2017 and we migrated in 2019. Now everything for us is on a big data. Most of Fortune 500 company, I would call it like 95% have already migrated to big data. Okay, so big data concept is storing the data in a form of a file system. When I say file system, we will study what is file system. It is called a HDFS file system, Hadoop distributed file system. And data is not stored in a single place. Data is scattered across. When I say data is scattered across, means data is distributed into multiple places and you can retrieve the data quickly because you are not going to search the entire table. So think about this way. If I have a big book of let's say 40 pages, if all of you come and ask me, I have to search for you every time, right? So if all 30 people come to me and start asking, can you give me this detail? I have to turn on the pages and give you the answer, right? Instead of that, I take the 30 pages and tear it out and give 1 pages to each of you, right? And now if 30 people come and the person knows which person to go and get the data from, the person has to read only 1 page, right? They don't have to read the 30 page to find where the data is. So that's the basic concept of Hadoop.
Hadoop is like a replacement for traditional system.
I will not call it as a replacement, it's an enhancement or migration, right? If your organization is small one, where the data volumes are not growing very frequently, then you can go with the traditional method, right? But the enterprise application, big organization, their data is growing massively. Think about YouTube is a classical example. Every minute we are uploading close to 1 terabyte of data in YouTube.
Still we are like, we are using the storage, right? But we are segregating it into small pieces.
We are storing the data in a different way versus the storing the data in traditional way, right?
Is it expensive like compared to the traditional data?
No. When you say expensive, depends on how you are using it. If you go for an Oracle installation in your organization, Oracle is a license, right? So if you go with Oracle and they set up your cluster and based on that cluster, end of the day, you cannot have everything on your office, right? So let's say I have a big organization, I can have 10 servers sitting here. Out of 10 servers, 2 are web server, 2 are app server, and remaining 4 are database servers. Broken down into 4 instances, instance 1, 2, 3, and 4, right? Tomorrow my data volume is growing. What I am going to do? I have to increase this 4 database server configuration, right? How much you are going to increase? The first method is you are going to increase it saying that, oh, I am not going to keep these 4 database servers in a physical way. I will put these 4 on cloud. But still the database still remains the same instance, right? So the cloud will charge you as and when they want you to grow. Versus if I go into the cloud and say, I will store the data in form of a HDFS file system. File system is nothing but a normal text file format. Smaller space, less less licensing cost because you're not paying for Oracle, you're only going to pay for the cloud usage, right? And retrieval is very fast. Don't worry, we will go into the detail how to set it up. It's practically very easy. Only thing you need to understand the concept of how data is stored, right?
So we, like, if an application is running like in your organization, do you need to have both the two systems, the traditional and the Hadoop, like
It depends, like most of our application, the application which don't grow that frequent, right? There are application like portfolio management systems where the data is very stale. It doesn't grow at that rate. Still it is in the cloud, but the traditional way of Oracle installation or Oracle instance running. But we have a major system which is running as a backbone, which volume of data grows every day or every minute. For that, we have a big data because we need to maintain that data volume. Someone wants to see a trading which has done 3 years back. I still need to hold that data, right? Because tomorrow someone comes and wants to sell that particular stock at that rate, right? And want to see how much profit he has made. I have to have the data for comparison and see. Because we have to see the graph and plot and everything, right? Okay. So application of big data and data analytics. What did big data professional do? Analyze bottleneck in the system. I will give you an example of each of them, how the big data applications are used for data analytics. If anyone knows, they can help me out. Can give another example also. Analyze bottleneck in the system. Anyone know how we analyze this in big data? No? Okay, so let's say there are 500 systems in your organization, right? They are out of that 500 systems, every machine is, let's say, i7 machine, what we have latest laptop. They are all connected to each other. I want to measure the slowness, which of the server machines are slow, right? What I'm going to do, I'm going to just run a small job continuously on every of 500 machines. The job task would be to collect the CPU, memory, disk utilization on that machine. A simple Python program, which you can write it and install in all the 500 machines. The task of that program would be to collect continuously the CPU, memory, disk of that machine, right? Usage, and write it to the text file. Now, when it is written, I can write it to a single source file from 100 places. Once I get that whole list, I can identify which system is slow using a program, right? By finding max, right? And that particular max command will tell me which system is slow and I can fix that, right? Second is detection of fraudulent transaction. Example is credit card usage, right? So if you're using a credit card, you are using through a user ID and a password. So when you log in, you create a session ID with an IP address and the location, geographical location, and all those details, right? It gets logged into the log file of the credit card company, right? If you are using Visa or MasterCard, whichever. Now, if that particular credit card is stolen, right, and being used from a different geographical location or a different IP address at the same time, or maybe which is not authorized to be used in the country where it is being used, automatically the system triggers an alert that this request is coming from a location which is not justified. The alert triggers and locks your card, right? Detection of fraudulent transaction can be like if cyber attack, right? So every day banks see a lot of cyber attack coming into the organization, right? How do we identify which one are legitimate and which are not legitimate? So there are programs that are written with a rule set defined. That's a part of machine learning. Rules defined, which continuously tracks and identify and evaluate each transaction and tell that whether this transaction should go through or should not go through, right? So you have, even in your, I don't know whether you all have seen, if you open the Seneca page, right? You log into one of the session and then you open a new browser and again log in. The previous session gets expired, right? How does it happen? Because you are although using the same credential, but every time you are containing two different session IDs. The server understand, okay, this is an expired session, it should be expired, then only I can allow you to open a new one, right? Similar case happened with the fraudulent detection, right? Build large-scale data processing system. Large-scale data processing system, Hadoop is used because if the data is coming from different sources and that data has to be fed in and ingested. Ingested basically means inserted, okay? So I will be using the word called as ingestion rather than insertion, okay? Ingestion is term used in big data to insert the data in bulk. Okay, so build large scale data processing system. Big data concept is used. Architect high scalable distributed system. Highly scalable distributed system means your system should be scalable enough to expand, right? So today you are using, let's say, one server, tomorrow it should be 4, 5, 10, 15, you should be scaled up, both horizontal and vertical. How many of you know horizontal scaling and vertical scaling? Anyone knows? Have you heard about the term horizontal scaling and vertical scaling? You all can tell me yes or no. You've never heard it. Yes, I have heard it. I don't know.
Yes, prof.
Like I read it in a cloud course that if you are adding more servers, then it's called horizontal scaling. But if
Correct.
you are getting up one big server, then it's called vertical scaling.
Yes. So vertical scaling means adding more CPU to an existing machine. Not only CPU, your main memory and disk. So if you have one laptop and if I'm upgrading that laptop to a higher configuration, then it is called as vertical scaling. Okay, so I'm going up and up, upgrading it to a higher configuration. That's called as vertical scaling. Horizontal scaling means adding new servers. So I have one, I will have 2, 3, 4, 5, right? That's called as horizontal. So my big data concept also includes architecturally highly scalable distributed system, building up that system that are both architecturally vertical and horizontal scalable, right? Why I need those machines to be scalable? Because my data volumes are growing and my processing capability needs to improve based on the transaction that are going to be executed on that machine. Find unexpected relationship between different variables. I gave you an example of ice cream and a shark. Another example will be finding unexpected relationship between different variable. Okay. So again, it's a concept of machine learning. We will do this as a part of our machine learning concept understanding, but I will give you a high level understanding. So let's say I want to identify how many flights get delayed in Toronto in a year. So let's say, and there is a relationship, sorry. Okay. So let's say there are two relationships here. I have a data set of all the weather throughout my year. Okay. Every day you have this weather channel, right? That records your weather. If I take all that weather data into my Excel sheet, okay. And I will have all the data of arrival and departure from Toronto airport of all the flights in the Excel sheet, right? Can I do a relationship to understand how many flights get delayed due to weather on a certain day?
Yes.
That's the concept of machine learning. You have to programmatically understand and analyze both the data and have a relationship when it is unexpected, right? It's unexpected relationship between two variables. One data is completely different of weather. Another data is completely different, which is related to arrival and departure of the flight. I want to analyze how many of the flights get delayed due to bad weather. So what I'm going to do, I will first understand the weather. I will take the weather chart and identify which day it was storm, rains, and whatever it is, right? And I will understand which days the flights were delayed. I will try to correlate. I will try to see, oh, flight got delayed due to what reason? Was the temperature at that point not good enough, or was a storm there? That's the reason the temperature got, that's the reason the arrival or departure was delayed, right? That type of relationship, if you have to do it, you need a big data as a part of your historical data set, right? Real-time analysis to monitor the situation as it develops. Real-time analysis to monitor the situation as it develops is an example of a stock market. Okay, I want to analyze, you have seen people seeing the graph for stock market, right? Right, you will see there is a graph going up and down, right? They analyze it with the bars which they see, right? That's a real time, right? They predict it how based on the data set they get, they analyze it using machine learning to see what's the prediction of getting the data value higher or lower. Here is what data analysts do: acquire, process, and summarize data, package data to derive valuable insight, design and create data report using reporting tools, spotting pattern to make recommendation and see trend over time. Okay, this is the task of data analytics. See, in order to understand big data and machine learning, you need to be more of an analytical. Okay, you need to ask me questions. Okay, there is no rocket science of learning big data. It's more you practice, more you will know. There are hundreds of algorithms to be used in machine learning. But if you know 3 or 4 good algorithm and understand how it works, you can solve most of the problem. Okay. Whenever you go in an organization as a part of a big data analyst or data scientist or whatever we call it, right? The approach should be that you understand the data. The more you understand the data, the more analysis you can do. Okay. So the entire concept of big data deals with understanding the data and then analyzing it. Okay. So you have to go through data multiple times to analyze it. It's not that, okay, you think of, okay, I do one problem and I will solve it, all other problem like this. It doesn't happen like this. You have to be curious to know how the data is changing. Top 2 2024 big data statistics are here. The handful of the most notable big data statistics we get started with. A global big data analytic market is worth of $348 billion. Around 2.5 quintillion bytes worth of data is generated each day. Big data analytics from the healthcare industry could reach 79.23 billion by 2028. There are currently over 44 zettabytes of data in the entire digital universe. 70% of the world's data is user generated. Cloud computing end user spending total amounts to 500 billion annually. It's going on changing every day. Okay, so we are not talking about gigabytes and terabytes. Now we are talking about quintillion bytes. Okay, each day we are creating so much a volume of data. Okay, so we need a way where we can use that data into a valuable sense, right? And that's the thing which industry also wants the next generation people to understand. Okay, if you see the current approach, how we are doing the software development, we are also doing the software development in understanding the client needs using their data. Okay, so if I go to a mobile app and if I start seeing that, let's say I go to a particular bank app, right? What do you do normally? So if I log into a mobile app, bank app, everyone has a mobile bank app, right? TD, CIBC, anyone. What do you do normally? Okay, you check your balance. What do you do? Transfer money. What else you do? Statements. Okay, so basically 3-4 things very commonly used, right? One is you just log into the application, go and check in account and see whether my account's data is correct or not, right? Second, you will do transfer fund, right? Third, maybe sometimes you will change profile, right? Other maybe you will see the credit card balance and all those stuff, right? If I take a handful of 10 to 12 things which are most commonly used, how should I take it out? How should I take that out? So earlier, I will give you a traditional way of doing it. Traditional way of doing it is, let's say a branch person comes to you and say that, oh, use my app. He starts doing survey with 500 people, right? And make a log of, oh, what are the common things they use? He comes back to us and say that, oh, these are the common things the person uses. Now we have more than 16 million clients in RBC. Do you think is it possible for us to go to every customer and ask how they are using the application? Right? What should we develop next? Not everyone writes a feedback, right? How many of you write a feedback if application is down?
We can check from the system if that service was called or not.
Correct. So every time when you use the application, what you are doing, we are logging in your events. Whatever you do, we log in. What are we? Okay, you log in with your user. We don't see your user ID and a password. We don't see your card number. We see partial of it. We log in and we start tracking your logs, event. Based on that log, we identify the different age groups. This group, this group, this group, this group. And then we identify and analyze, okay, this many people use this particular services of the app mostly. This section of the age group uses this. So maybe I may design an application for an elder of 75 plus using an app. I make it giving him the features which are most commonly and easy for it to use. Because that person will mostly use what? Check-in account, seeing the balance and log out, right? But the age group of 18 and 25, I know these people are very good in taking subscription. So when you log in app, I will just show you Spotify. That's an AI, right?
Yeah.
What I'm trying to do, I'm growing my business with your usage pattern, right? Same thing happens in any of the Amazon, you purchase anything, right? What we are doing, we are tracking your history and logging activities, and based on that activity, we are analyzing it and giving you the most recommended things which you are most likely to buy or purchase, right? Same thing we do it in the app also. Earlier, we used to get a requirement from our BAs, right? Oh, my client says we need this type of application. Now we are tracking all these activity using our AI tool, getting all the analysis, understanding where the application is most likely being used. Let's say a person goes, every person logs into the mobile app for bank and goes to check-in account. I need to make sure the check-in account always work, right?
Yes.
So I need to make it reliable, because if, let's say, 1 in every million customer fails to see the check-in account, that customer is not coming back, right? So I need to make sure that that service is always up and running. And for that service, I need to make sure that the system or the server behind it is very reliable. It never fails. How many of you go in FAQ? Very rarely, right? I will not keep a heavy server for it. I will have that FAQ response kept in a very low performing server, because I know 1 in every 20,000 people will go and check FAQ, right? So that's the way we are designing the system, so that the usage, based on the usage pattern, based on the logs which you are giving it to us as part of your activity, we are logging it, analyzing the data and building the system based on it. Okay. Why it is big? Technology, extra large volume amount of data up to terabytes, non-structured and structured data mix. So we will discuss more detail about non-structured and structured data mix in upcoming slides. Widely distributed source of data, because our data is scattered across the places. We are getting the data from different sources. Okay, as I told you, now data source is not one system. Earlier, it used to be only one system where your data source is coming from. Now I need to get the data source from many other systems. You might have seen that there is an application which is a travel site, right? And they will have a weather also, right? How come the weather information is coming in travel site? The usage is, okay, someone is viewing a travel site for a certain location, wants to go to Cuba, and particular day it will also see on the right hand side of the weather in that day, on particular day, what's the weather on that day. The data is coming from two different sources, one from travel site, another from weather rate. So your data is coming from a different distributed sources, and you need to collate all the data to do the analysis. Okay. Vague query, no predetermined results. Okay. So big data has one of the biggest advantage called as vague query. The query which cannot be defined. Okay. Temperature is very hot today.
Yeah.
What do you mean by hot today? It's very cold outside. How will you define cold? So if somebody gives you that type of query, you see in Google, right? Google is a classical example of vague search. You put anything, it will give you a data, right? How does it give you? If you write a SQL query, let's say I want to fetch something from a database, what you will write? Select star from table name where A, B, C condition, right? And then you return it. That's a structured way of extracting a data from a database. But not all query in real times are structured. They are unstructured. People are asking anything. You write any word and you will get an answer in Google. What is happening is, using a vague query with no predetermined results, the search engine should work. Okay. It uses the concept of NoSQL. Anyone has heard about it? No. We will study a little bit of NoSQL and HSQL. Okay. Queries are built steadily, step by step. So whenever you give a vague query, right, the query is not parsed and given in a single go. It's broken down into smaller section and then parsed and extracted as a part of result. Okay. New services, Internet of Things. How many of you know IoTs? What is IoTs? Connecting devices, yes. Like? Arduino.
Raspberry Pi.
Okay, you are telling me something which is, I'm asking about an example. As a layman, tell me what is IoT. I don't know what is IoT. How would you explain? The smart devices. Exactly, the smart devices. My mobile app has a tracking system which tracks how many steps I walk. Right? Yeah. I gave you an example of a thermostat device that is kept in my home, which maintains an temperature in my home, right? Whether it is cold or hot, right? You set it up certain temperature. If the temperature goes below that, automatically heat system starts in, right? If it is warm, the air condition kicks in, right? IoT, Internet of Things, are the devices which stores lots and lot of information, right? So IoT is also used nowadays to, okay, how many of you have seen, again, in back home, every month you used to get electricity bill, right? Electricity bill and heating bill. So I'm talking about 15 years back, what used to happen? A meter was there, somebody will come and note down your reading, right? And then they will go back, take the reading and then subtract it, and based on that, they will put some rate and give you the electricity bill in your home, right? Does anyone come to your home nowadays? Then you are staying in a village, right? So now what's happening is your electricity and your heating are all connected in IoT devices. Okay, what are they doing is they are continuously tracking your readings, right? So I will give you an example, advantages and disadvantages. First, understand every time they are tracking your usage pattern, right? You can also say day-wise also usage. So if anyone has an Electra account, Electra or Enrich heating and accounts, right? So if you log into the application, you can see day-wise, hourly-wise usage of your electricity or heating, right? How they are doing it? Every time when you're using certain services, they are tracking and capturing those event of usage and logging in somewhere. And when the data is logged in, it is presented in the form of a data analytics report to you. Okay, on particular day, you're using high electricity and particular day it's low, right? So that you can change or adjust your usage pattern, right? Advantages is you can also see that if you are traveling, right? So let's say I have turned on my air condition light in my home and I forgot to switch it off. I can switch it off from my phone, right? I can shut down my entire house through my phone, right? That's an Internet of Things. You can perform many services through your mobile app or a desktop application. The services which are storing your information, right? Like your electricity bill, nobody comes to your home. It automatically gets triggered in certain month, a particular day, a batch job will run from your customer ID, starts and end date, and whatever duration your usage is, it will collect that information and create a bill for you and send an email to you. There is no one sitting down there and capturing everyday details, right? So all those informations are used for big data. The most important, I think, Internet of Things are largely used in a scenario where it is critical also. Like if you have a thermal power station, right? Everyone understand thermal power station? The electricity generated through fossil fuels, right? So you have electricity generated by steaming up the water, right? And that turns a turbine. If a particular point of time or pressure goes beyond certain limit, what will happen? What will happen? Sorry?
They turn off and switch.
They will? So you have a thermal power station which has got a boiler which continuously boils the water and convert to steam, which turns the turbine, and the turbine generates electricity, right? Right? Yeah. There must be some pressure gauge, right? That maintains the pressure, because beyond that pressure, what will happen? The boiler will blast, right? So there will be a safety valve. Earlier, what used to happen? A person will sit there continuously 24/7, monitor the gauge, right? As soon as it goes to a warning state, it switches off, right? Cut it off. Do you think now they are sitting? It's not, because now every details is being tracked by sensors. Sensors are collecting each and every minute of information in form of a log, and that logs are continuously analyzed in real time. And based on that analysis, there are alert systems set up at different levels. If the alert is this, shoot a warning to everyone. If alert goes beyond this, shut down the plant, right? So it automatically happens, right? So Internet Things are the next way of usage of big data. Internet is a network of physical objects that are fitted with sensors, software, and other technologies connected to the internet. These things are able to exchange real-time data with connected device and system over internet. These connected device combines with automated system to gather Internet of Things data. that can be analyzed, assessed with the task to learn how to improve a process. Despite of many positives provided, okay, I'm not reading last line. Do you think there is a drawback of Internet of Things?
Your brain is getting.
Security.
Privacy. Yeah, privacy is the biggest challenge with the Internet of Things, because if you are connecting your mobile devices with any of the devices in your home, basically you are vulnerable to anyone who hacks it and uses, right? Or even the company which is, let's say I'm using a internet through my mobile app, which is hosted on Bell Internet, right? Bell has all the information of what is my usage pattern, right? What I am using, right? How do they know that what I need in my home, right? So let's say I am thinking of changing my digital lock. Let's say an example, I want to change a digital lock to get a more advanced version in my home, okay? I'm thinking because that digital lock is very slow. Let's say, for example, for locking, it's not as efficient I want. I'm thinking, but see how the data is analyzed. Since that system is already connected to my internet using Bell, Bell also has that information. Okay, whenever I'm locking the door, whenever I'm opening the door, that log information is also going to Bell, right? They know that, oh, this particular system, digital lock system in his home is not performing well. Let's sell him. I'm just thinking this, the person will come to my home and say, oh, do you want ADT in your home? How do they know? I never asked them, right? But the details are already there, right? So those are the things which is big data has a challenges in terms of privacy. So in the banks also, big data is used most of the places. Only one place we are not using till now, big data, that is on insurance. Machine learning and big data is not used on insurance. Anyone has an idea why? We are moving to more making the system intelligent enough to handle most of the queries of the customer. But insurance is a place where machine learning is not so skilled. For example, if you have an insurance and insurance says that if you hit an accident, you have to pay a fine, or let's say insurance, you can claim an insurance, even if it's your mistake or not, right? If you design a machine learning algorithm with certain criteria, right? If that criteria doesn't fit well, the insurance is denied, right? Versus a person is a physical human sitting there, you can convince that person, right? Right, sorry, sir, I did it by mistake. Please give me last warning, right? As you all will do, right? Professor, we cannot complete your assignment. Please allow us one more time. And I will say, okay, fine, do it. But machine will not do it, right? Machine will say, okay, you cannot submit it. Sorry, next time, right? So that's the place where we are not so aggressively moving, because insurance is a place which is a bit dicey in managing the machine learning, AI, big data. Okay, so now the concept comes structured versus unstructured data. Structured data typically categorized as quantitative data. It is highly organized and easily decipherable by machine learning algorithm. Structured query language is a programming language used for managing structured data. Structured data basically means a simple SQL data set. The relational database system which you have used till date is called form of a structured data. Any data which is being defined by data types, stringent, data is getting inserted on those columns, that data is structured. Another example is every data, let's say there is a data set in a text file with comma separated, CSV. That's a structured data, right? You can take a text file with comma separated, import in a Excel, right? That's a structured data. By using relational database, business can quickly input, search, and manipulate structured data, right? You can easily query it, you can insert it and all this. How many of you understand relational database? Relational database means relationship between the tables to extract the columns. Do you remember normalization?
Yeah.
First normalization, second and third. Anyone? What is F1 and F? Removing duplicate data, right? Every data should be, every row in a data table should be unique, right? In terms of a primary key constraint, right? What is second normal form?
Unique and consistent.
No, it should be unique and
Non-transitive.
Non?
Transitive.
Non?
That's in third eye.
Second normal form. Third normal form. Second, you don't know, how would you know?
Third one is being transitive.
Second one is if you have a relationship between primary and foreign key, the primary key can be foreign key in another table and have a relationship as an entity relationship diagram, ER diagram. Okay. Pros are easily used by machine learning algorithm, easily used by business user, accessible by more tools, right? You can use SQL, you can use any structured query language which you want to use.
So I have a question regarding Hadoop. Like you are mentioning that most of the companies are moving to Hadoop. So if I'm designing a website in traditional way, I'm just writing a query that like I'm calling an API from front end and query is returning the results. So how does Hadoop work? It takes queries or like
You have to change your query to a NoSQL query. Okay. Again, the syntax still remains the same. So for as you have asked, right? So we have a front-end application and a back-end system called as single store. That is a Hadoop type system. In between, we have a database schema, right? The query which is written there, right? We convert it explicitly to that particular format because we don't want to rewrite the same query again and again, right? It's a very tedious job. We cannot write 50,000 queries which are written there, right? So whatever is already written, we convert into the format of that language where the data can be fetched. For the new ones which we are developing, we directly write it in the new format. Okay. Again, your stored procedure, your what you say, your data type still remains the same. So you can use integer, double. Only thing what you cannot use, which you use in SQL, is auto increment. You remember auto increment? How many of you remember auto increment in database? When you create a table, right? Create table, table name, column XY, auto increment. What does auto increment does? It increases your primary key by 1. Hadoop, you cannot do it. There is no concept of auto increment in Hadoop or single store or Databricks. They don't have this concept because I will tell you why. In case of a normal SQL, your entire table is stored as a single unit, right? If you have 20,000 records, it's a one table, right? So if you have to read the table, you go row 1, row 2, row 3, right? If you have to jump to a certain column, a certain row, you have use index, right? You go to that index and pick up that data. Since Hadoop data is split, right? So you are, let's say one file is of 10,000 record, 2,000, you have 5 set in 5 different places. How can you have an auto increment? So there is like 1 to 10,000 will be there, 10,000, 1 to 20,000, 1 will be another machine, 30,000, 1 to 40,000 will be another machine. So there is no concept of tying it together, right? So the concept of, if you all know, if you have studied pointers in C, right? The similar concept of pointer is used, which is called a shard key here. So you point it with the key value. So we'll study how key value pair works. Okay. What are the cons of the structured data? Limited usage. You cannot use a vague query in a structured data. Limited storage option, very difficult to scale. Structured data tools are OLAP, SQLite, MySQL, PostgreSQL support SQL and JSON query, as well as high-tier programming language C, C++, Java, Python, etc. Okay, this is a normal structured query way of accessing or extracting the data. Use case for structured data are customer relationship management systems, CRM systems, online booking or accounting system. Okay, the very basic ones you can use your application using structured data. Okay.
What feature actually Hadoop used to scale up, like Docker or something?
It uses the combination of cloud with, okay, so there is a concept called as auto scale.
Docker.
Similar to that, Dockers and Kubernetes. So there is a concept that whenever your database goes beyond certain size or configuration in terms of volume, it spins up a new database instance and stores the data in that format. I will explain you on Hadoop. Okay, don't worry about it. I know it's for other people, it's very new, but don't worry. I will try to be very close to very simplistic way of explaining you how we are doing it. It's not a regular way of just spinning it out. You have to do architectural design how to do it. Okay. Unstructured data typically characterized as qualitative data. Since unstructured data does not have a predefined data model, it is best managed in non-relational database, NoSQL. Okay. Another way of managing unstructured data is use of data lakes to preserve it in a raw format. Data lakes is one form of big data. Okay. Again, it's a company term that is used by companies, data lake, big data, and all those stuff. Okay. Example of unstructured data include text, mobile activities, social media posts, Internet of Things sensor data, etc. Okay. Pros are it is in native format, means it's in the raw format. Fast accumulation rate, since there is no need to predefine the data, it can be collected quickly and easily. So you can collect from any source of guys. So you can collect the data easily from different sources and get ingested. Data lake storage allows the massive storage and pay as you go use. I just want to put those down. But oh, sorry to bother you. I didn't want to. What are the cons? It requires expertise in understanding how you handle big data. It needs a specialized tools. Unstructured data tools are MongoDB, DynamoDB, Hadoop, Azure. Hadoop and MongoDB is similar. Okay. If you know Hadoop, you can easily understand MongoDB. Okay, don't worry about the tool. Understand the concept and how it is going to be implemented. Conceptually, it's used same as it is. Only the syntax gets changed. Most of the organization where you will work as a big data analyst or data scientist, you will not be allowed to initially handle the Hadoop system. Okay, it's not a playground area. Okay, so you will be able to see, you cannot update, you will not be allowed to make changes to the Hadoop file system, but you can retrieve and execute your programs. Okay, Hadoop system setup and design happens by the architect. Once you go more experienced, then only they will allow you to do it. Okay, because it's very sensitive in terms of data management. Okay. And you are not dealing with 1 or 2 gigabytes of data, you are dealing with 1000 terabytes of data. Okay. Use case for unstructured data is data mining, predictive data analysis, and chatbot. Data mining is extracting a useful data from the existing data set. Predictive data analysis is like predicting a weather temperature for the future or forecasting it. That's a predictive data analysis. Chatbot is more of a, you all have used chatbot, right? Help desk, right? How does it work? So you write some sentences, right? Based on that sentence, what it does, it picks up the word, right? Based on that word, it searches this database with common matching. Based on that, it gives you the reply, right? Most popular use case, major trend in using big data technologies are in operations. Use cases achieve high speed of processing responses, online archiving, decision-making process in business. Decision-making process in business are like example of Amazon, which I told you, how the business should grow based on your track of event which you are doing. It tracks it, and based on that, it suggests you what you should purchase, right? And it increases your business, right? I will give you another example. So we were building one feature in one of the application, which we thought that it is useful for the business, right? But based on the usage pattern, right? We have completed half of the development and we're just going to launch in next 3-4 months. And we came out to know that nobody will use this, or less and less number of people will be using it, right? So we canceled that program or project, right? So how did we get that information? Was decision-making process in business by analyzing the data. Cybersecurity and risk management, operational analytics in everyday business operation to enhance business process, example, logistics. Operational analytics, example, logistic is means, so you have, all of you have gone to Walmart, right? Everyone has gone to Walmart, right? Can you tell some of the unique feature which Walmart has when you go in-person shopping?
It has every parts of the thing, like laptops, from groceries, everything that is included within the Walmart.
Okay, so it has all a different variety of products. Okay. I want to understand any other thing you have analyzed it. again, this is very common in Walmart, Costco, or I should call it.
You can buy in bulk.
They try to cover all the culture for like.
You can buy wholesale.
No, that's fine now. Wholesale, others are also giving, right? But now more or less every company is following the same trend. So if you go to Walmart, right? The structure of Walmart in every store is same. Every place, every store is same. Have you ever thought of, if you go to the left-hand side, I'm just giving an example. If you go from left-hand side, you will find vegetables.
Yeah.
Or bakery will be adjacent to vegetables, right?
Yeah.
Right? If you go to the first aisle, it will be maybe certain type of food. Second, if you go to the last, you will find milk bags. Right? If you go to the complete other section, you will find all the cosmetics, right? If you go to the back side, it will all toys. What's the use of it? Have you ever thought of why that has been set up like that?
So that if people go to a different branch, they can, it's the same thing.
Exactly. They don't have to search. If you are searching, it's very likely that you will not buy it. If I go to a store where I go and start searching, where will I find, and then end of the day, leave it, I'm going. Right? You get frustrated. But if I tell you that every store is exactly the same, you go to one Walmart, two Walmart in your locality, and suddenly you go to Oakville, or suddenly you go to, let's say, Calgary. You go to Walmart, it's still the same. So if you have to buy an electronics item, you know it's in the backside there. What I am doing? I'm analyzing your purchases, right? So this is one of the concept which makes analytical data to be understood, right? Second is you will always see that the things which you need very commonly, it's the farthest from your place. If you want to buy a milk, you have to go all the way to Walmart end. Why? Why not they kept milk in the front?
You'll see all the products.
Because if you keep in the front, you take a bag and you go out. They lose the business. So they keep at the end. So in order to buy a milk, you have to travel all the aisle to go to the end. In the way you will find some or odd things on the side and you will pick it in your bag, right? Right? How did they come to that concept? Somebody is studying it, right? You may not be studying it, but people are studying this and understanding that analytics, and based on that analytics, they are putting the things in perspective. Let's say you will always see when you exit any of the stores, all the fancy stuff, right? Chocolates, and they are kept in the counter. Why? Why?
They should remove, but giving there last minute, like you want use on.
There is again a strategy there. When you see Walmart has 10 counter of checkout. I'm talking about the manual ones. Only 3 will be opened. Why not all 10? Why not all 10? They have a manpower, right?
Wait in the line and look at
the more you wait in the line, what will you do?
Look at the stuff.
You will buy unnecessary things, right? That's the way they are selling the product. You go to Walmart to buy a milk, you end up buying 10 different things except the milk. Right? It happens to everyone, right? It happens to everyone. Why? If you see that Walmart is also not purchasing based on the sale they are based on the supplier they are buying it. So let's say Walmart is buying tomatoes from some local farms. Okay, how do they are like? What's the strategy for them to buy? They're not buying in bulk. They are buying in bulk when the sale is in bulk, right? So the system is auto trigger. So let's say they put tomatoes in a certain section, the basket in certain aisle, right? And they start seeing what is the sale that is happening through their checkout, right? When you bill it, right? The data is going, right? The volume of sale of that particular tomato in certain week is high. It automatically triggers an invoice to the farm saying that I need more tomatoes. The next week it sees, oh, sales have dropped, tomatoes, nobody is buying. Oh, don't call supplier, don't send the invoice to buy new ones. They are also not making a storage. It used to be 10 years, 5 years back that, okay, they will make a big warehouse and they will keep all the stuff. Why will they keep 500 bags of rice when nobody is buying a rice, right? Because at the end of the day, Walmart has to pay the suppliers, right? If the sale of rice is not happening, why will Walmart make a loss, right? Based on your usage pattern. They are also doing a lot of things now. If you see, first Walmart used to have a camera in front door, right? Security surveillance camera. They used to say what? Somebody is stealing, they want to stop it, right? No, that was not the cause. That may be one of the reasons they have put the surveillance camera. The second reason was they want to see the traffic of people coming in and out in particular time period. Why do they need that information?
See when they're most busy, what time of day.
So if they see that, okay, particular time from 2 to 6 it's most busy, I will have most of the employee working at that time. Why I need 10 people working at morning 9 to 4 when there is no traffic? I need 10 people working from 4 to 9, I will have more manpower there. I will have less manpower in the time when it is low, right? So they are putting a surveillance camera nowadays in every aisle. Why? No, shoplifting is only 1% of that business loss. They are going.
Items are being sold.
Exactly, they want to understand what is your trend of purchase. Most of us purchase using credit card, right? If I'm purchasing every week or every 3-4 days in the Walmart and I'm using my card, what are they doing? They are tracking how many products I'm buying. They are doing the correlation, understanding what type of material I'm buying. Based on that material, they will make sure that based on the usage pattern of most common people, keep the items the places where it is most commonly picked up. Right? Don't keep something which is never picked up. Okay. The real-time provisioning of goods and services. Hybrid data ecosystem, one of the strongest trend of data architecture today is towards environment consisting of numerous data platform where data is physically distributed across multiple data server, file system and storage devices. I have explained you. Hybrid data ecosystem means data stored in a different format in different sources. EDW is one of the example called an enterprise data warehouse, is a centralized repository that integrates and stores data from various sources. Data mart, simple form of data warehouse that focuses on single subject or line of business such as sales, financing and marketing. Example is Walmart. Operational data sources called as ODS, like your radar traffic data detection, right? You will see that here in Canada, most of the traffic light are traffic sensitive. If the traffic is very high on a certain roads, you will see the green light being longer versus the traffic which is lower on the other side, right? Analytical database platform application like historical transaction that include purchasing pattern for improved marketing. I explained you that. NoSQL data source store platform like non-tabular format to store data rather than rule-based relational database. Like relational database, NoSQL example, Tableau. Somebody asked me, right? Yeah. Data discovery platform is a data visualization tool that accesses reporting information, spotting anomalies, complying with regulatory obligation and tracking informed decisions like credit card fraud detection. Cloud-based data solution is a model in which data is stored and processed on the remote server rather than on-site server using cloud-based system. Okay. 2 more minutes.
You're done 2 minutes.
Oh, okay. Okay.
I need time to prepare. I'm sorry.
Sure, sure, no problem. We'll cover in the next class, okay? Sorry, I just closed that. Today was the first class.
Yeah, same with me.
Yeah. I will just look at outside, okay? Yeah, I will look at outside, okay? I need to read the yeah, yes, that's it. It takes about 5